So I'm showing the agenda for today. So Per, you first.
Yes. Did you get my presentation, or should I share it from here?
You can share it.
Yeah. Let me see. There it is. I have. Can you see it all?
No.
We see your team screen right now.
Yeah. Okay. Try again. Is it now?
Yeah.
Okay. Okay, so on behalf of everyone in the project, all the participants and myself, I would like to greet you welcome to the first ever virtual hackathon we're doing here. We would of course have appreciated if people could meet in person, but that's not really possible in the times like this. And what you see now are the fonts and the styles for Unimatrix according to the name and the logo and everything that we have just completed the handover to Linux Foundation. So from today we can use this openly. We will get the website out there as soon as possible. I think Will is a little bit busy right now, but as soon as he has some time over, he will make that happen. So welcome to this Unimatrix Virtual Hackathon. We have 3 days ahead of progress for the project, where we will do a lot of collaboration and sharing of ideas. And I trust that we, by the end of this, would have some new experiences that we can share and definitely bringing the project further. So what has happened since we all met in Malmö in December? Well, apart from having some some new members, we're now up around 10 active companies. And we really haven't started the recruitment of new members. We have been responding to requests and questions that are come in. And I think we're better established now when we have the basics arranged. So as I mentioned, we have the name and logo established. The website will go live today or tomorrow, I hope. You all share the visual guidelines and the logotype that we can use. We have a governance board established where we run regular calls. I think since we met in Malmö, we have held like 6 calls. In the process of getting ourselves handed over to the Linux Foundation, or operating under the umbrella of Linux Foundation, we also established a technical board. The charters have been circulated and will be handed into Linux Foundation, I think today or tomorrow, so they can go ahead and register the entity to make it an official project under the Linux Foundation. And as said, we have the virtual hackathon today and the next coming days until the 18th of June. Do we have any questions that anyone want to pose at this point in time before we get going?
Excuse me, let me confirm about the schedule of day 3. It announced a 1-hour session, and it begins from what time? 14 o'clock UTC in 1 hour. Is that correct?
Yeah. You think 1 hour is not enough?
Probably,
I thinking we are four at this point. At least we are 4 different groups that have task groups. So I think 15 minutes per group. I was thinking, or you think we need more time?
I think it's enough. Any other comments from other person?
Okay, so that concludes my very brief introduction and welcome to all of you. And I hand it back to Frederick.
All right. Okay, can you see my screen?
Yep.
Okay, so here's the agenda. So I'm going to do a presentation now that is update on the goals. Then we have a presentation from Panasonic, and then we have 3 different presentations about the resource estimation.
Sorry, from Hackathon, we don't prepare a presentation for that part. For the resource estimation.
Oh, okay.
Sorry, yeah.
So I'll start with the presentation about the goals. So my name is Fredrik Svensson from Axis. So I'm chair for the technical board. So the goals about the video API that we defined, beginning of the year. It was these 5 goals. So define a subset of OpenCV, implement the API, package API in container layers, define a test suite, and implement the test suite. So the use cases defined was to capture raw video frames, to get some frame properties like timestamp, resolution, video format, FPS, to be able to set some properties like resolution, video format, FPS, convert color space, and to draw text and graphic overlay. So I propose to start a new working group on this to focus on the video API. So the idea is to write a specification that specifies which video formats that are supported, which different capture properties that you can get and set, and which algorithms that are required from OpenCV. Also, the working group should define the layer structure for the containers. So which base image we should use, like Debian or Ubuntu or something else. And as a base layer, which is like based on OpenCV, the C++ APIs, and then on top of that, a Python layer. So that's basically my idea about how to get this work item forward. There's been some work done already, but it's not really formalized. So I would like to ask the ones that are interested to sign up for this working group. Also, another idea I have is to implement a driver for OpenCV, for Unimatrix driver. So this driver would be common for all hardware platforms. It could use a database as an interface to capture properties. For example, it could use Redis. So Redis is a basically you can use queues in Redis to have timestamped properties per frame that automatically expire after a certain time. You can do zero copy by referencing frames with file descriptors. So it would be a common API, but you can, for your specific hardware, you could implement a backend in Redis for reading and writing these properties. So there will also be an interface for setting properties. And then I would like to upstream this driver to the OpenCV community so that it gets packaged into the normal distribution. Any comments about the video API? We also have a slot to talk about this during the technical board session, which is at the end of the day. So you can think about it. Is it a good idea? Do you have other better proposals?
I have a question here, Frederick. This is Sriram.
Yep.
Are we looking for some kind of embedded version for Redis if it is there in the community, or this Redis comes into play only for some kind of hybrid scenarios?
No, it's in the device.
Okay. Yeah, thanks.
Okay, next is inference API. So earlier this year we set up these goals. So define an API, inference API, implement an engine, and on top of that should be the TensorFlow serving API on top. Basically, the requirements that it allows for zero copy, that it's agnostic to the underlying model, so that you can have different backends that support different models. And so the backends that was added initially was TF-Lite, Google Edge TPU, and also OpenVINO. But I suggest to remove OpenVINO and add the umbrella CVFlow model. Also, the engine, you should be able to use any input-output tensor format.
Sorry for interrupt, Frederick. Respect to the backend model, maybe Howard Huang will propose the Spur model here. With him little late.
Sure. We'll have a session about the inference API later on. So I think there is a session for Huawei to present.
Yeah. Okay.
Right. So we presented LAROD in December. Basically, it satisfies the requirements that were defined there. So we propose to promote LAROD to the official Edge API. So we can take a formal decision on the technical board. Also, it's possible to implement TensorFlow serving on top of LAROD. There we have a prototype of that was actually used in December in the hackathon there. So it's a proof of concept. It's not really finalized. And LAROD, it's an open source project, so it's open for your contributions. If you want to do a new backend, it's possible. We might want to move it from GitLab to GitHub though. I think Ewan from Axis, he will present, he will give an update on what's new in LAROD since December. Are there any other comments about the inference API and engine? All right, so we go on to the deployment API. So the goal that was set up was to implement Containerd API. This is solved by just including the Containerd package. This gives us the gRPC API and a REST API. Also gives a simple command line tool called CTR. This can be used to pull Docker images, container images, and run them also. So we can get by without using Docker in the edge device. But is this enough for us? Do we want some other tools or APIs on top of Containerd? So how do we actually deploy and run the apps? So we could use the Containerd API directly. So a client can use the API to deploy and run containers. We could use something like Ansible as a front end to the Containerd API. We could also implement the OnWith app management API. So a good proposal is to implement a service that implements the OnWith API and accepts OCI images and runs them using Containerd API. So that would be an interesting contribution if someone is up for it. Another idea is to use Kubernetes for deploying and running apps. So we have KubeEdge from Huawei and others. It's an open source project, but Huawei is contributing to that. There's other companies like Red Hat and yeah. Another idea is to have use a virtual kubelet, which then you don't need to have Kubernetes on the edge. So you would have the kubelet running in the master, and then it will use another API, like the OnWith App Management API, for example, to deploy the apps. So I think about this, we certainly need more discussion about it. Also thinking about right now the size of things, like running Kubernetes on edge is still quite big. Are there any comments about deployment?
I have a question about like big. What define big? Because I'm not from the edge world, so 50 megs is big, or yeah.
I would say, I mean, from Hikvision's side, how big are your device images? I heard something like 32 megabytes, or is the normal size?
It's very difficult to say 2 megabytes it's enough or not, because anyway it depends on product lines, and you know, we have different product lines, and for most professional product lines that should be okay, we have such a capability. But for some low-end product lines targeting to small business, and for this kind of product, we don't think our hardware have such capability. So it really depends on what kind of target product lines we use for Unimatrix, and also I think the main goal inside of our inside of this organization is that we need to reach out a commitment on some kind of a hardware requirement, right? And we need to take consider of other manufacturers, including Panasonic and Axis and others. Yeah.
Yeah. We'll get more into resource discussion later on. Anyway, I think maybe implementing the on with app management API could be a good middle ground for these devices that don't have a lot of resources. Okay, so next API on our list was the audio API. So from the goals document, we set up goal to investigate different audio frameworks. Axis has started this. We don't have presentation about it right now, but Pipewire looks like a good candidate so far. It's the audio framework chosen by Automotive Linux. So there's quite a lot of activity going on around this. Then capability API. So we want to have a capability API that the use cases were to query with capabilities for imaging and PTC, so that if you write an app using OpenCV, that basically you will know what kind of properties that you can use from there. We will have an update from Hikvision about this later on.
Yes, but I think that there is not just requirements for capability API, and also other like host information API. This kind of information also needed from the host OS.
Sorry, you need it from where?
No, I like the MAC address or some kind of this information to do the license check, like this kind of use.
Yeah. Okay. Yeah. Yeah. The use cases probably can be expanded a bit. So I think we should update the goals document with what use cases we have.
Yeah, we can make a decision about the approach. We provide the API, and then we make a API requirement list.
Okay. Thanks to Panasonic iPro for Yusuke-san for his work on starting to use issues in GitLab so we can track the different tasks. So please, you can read his document about how to use the issues in GitLab. So basically, all the goals that we set up are now issues in GitLab in the governance project. You can use labels. So blue labels are used for marking which companies that are working on a specific task. So, for example, if you're interested in the video API things, you can put your company there, company label. There's already some labels set out. I'll show you a bit how it looks. So this is the GitLab page. So you go to issues. So there are 13 open issues. This corresponds to the goals in the goals document. Also, we use the yellow label for marking which domain it is, or if it's video API or capability API or audio API. So for you that are interested in the video API, please, I see Huawei, for example, they want. So if you want to join this video API working group, you can add your tags to these tasks. Also, in a doing label can be used for marking which tasks that are active. And then you can see in the board what we are working on. That's my update about the goals. Do we have any further questions? Then just let me go through the list and see who's interested. Who would be interested in joining a video working group from Hikvision?
Yes, we can work together.
Huawei.
I should say this. Yes, and I will check with my other colleague about the detail of the task.
Okay.
Probably yes. Yeah.
Okay. From Panasonic.
We also need the confirmation with my colleagues.
Okay.
So let me check.
And Focal.
Morning, Frederick. Yeah, we may, pending some discussion with the technical board in the next couple of days, have someone coming aboard who might be a good fit for working on that.
Good. I guess there will be some test suites and running on different platforms that could be interesting for you.
Yep, that would be the idea. Yeah.
And from Genetech.
Yeah, I think it's going to be the 11th, the implement video API for reference platform in a specific place of the video ingest.
Mm-hmm. Okay, so I think we have like a critical mass of interest in this. So we will probably we want to involve the whole group, so we will have separate telco about the video API. All right. Then we're running a bit early on the schedule. I don't know if we should wait for the time that is announced in the agenda, or we just carry on. From Panasonic side, how long do you think you need for your presentation?
Yes, I about 10 minutes presentation and 10 minutes question and asking questions. I expected.
All right. Okay, let's take a 10-minute break then and start again in at the announced time. So 10:45.
Hi, Frederick.
Hello, let's continue then. So I hand it over to Panasonic iPro for the grand design presentation.
Yes, okay, thank you. Can I my screen?
Yes.
Can I just see my screen?
Yeah, we
Yes,
can see.
we can see that.
Okay, and I'd like to thank you for giving me the chance to speak here today. I'm Yusuke Ogata from Panasonic iPro Sensing Solution, and today I am here to talk to you about two items. And the first is about grand design, and the second is the utilization of grand design. I make the grand design presented before more simple. Currently, 3 areas are under consideration. The first is the API inside the edge camera. The second is an internal interface for management. For example, deployment API, capability API. And the third is interfaces for data transmission to the server side. And in addition to them, we are studying test and evaluation tools. Looking at the grand design, you can see that no consideration has been given to the server side. If the data taken by the camera is hard to use the server side, Unimatrix may not progress. So iPro will continue to consider whether Unimatrix can do anything on the server side as well. And about the utilization of grand design, we hope to make it easy to understand the mechanism and advantage of Unimatrix with a grand design. And iPro want to make use of 3 things. The first is promoting collaboration between Unimatrix members. The grand design makes mutual understanding deeper, with grasping the relationship of components and interfaces. And secondary, we would like to utilize it for finding issues. The grand design make looking over the or and understanding the relationships lead to the discovery of unexamined areas and new issues. Third, we would like to appeal to our partners. So we are working on 4 things. We've already almost explained about them at our previous meetings. This time, I will explain about use cases. We want to accelerate the extraction of use cases and tasks using grand design. Especially, we are trying to extract use case on the server side and use case when adding applications. We examine the operations required to control API applications. there are use cases. Deploy application, start pod, stop application, set configuration, update machine learning data, update application, else check for application. Most of these can be achieved with commands of the container or on beef. Only the method of setting the config seem to depend on the application. However, I think if we get providing for tools that take time to develop, we can get Unimatrix more attractive. So we will make a tool for the setting that are often used in AI applications. I think setting the target range for detection as one of the common use case in AI application. We would like to create a tool that displays the GUI screen and acquires coordinate of mouse clicks. We would like to contribute to reduce the development cost for developers. So iPro will continue to update the grand design and use it for task extraction and joint work. Thank you for listening. Now, if there are any questions, please comment on the questions. Thank you.
Hi, I have a question. This is Rita from Access. Yeah, you have mentioned like something like relocating container. What do you mean by relocate container?
Yes, and this right, and you.
Yeah, in application use cases, you have mentioned some set configuration commands for relocating container. So can you just clarify a bit on what do you mean by relocate container?
Yes. Could you confirm your question? We have to set when we have to set configuration. We do relocate container, right?
I don't know. Maybe I'm not getting the English word right here. I mean, I'm not able to visualize what is relocate container. You.
Yes. Yes. I think. You're right. Container relocate container is okay, but if we want to get coordinate of the image coordinate of the image. It is easy to get the coordinate image coordinate with GUI. So,
Okay.
リロケーションのオブジェクト、リロケーションの目的って何でしたっけ？
ロケーションの目的。
うん、なんでリロケーション必要なのかっていうのは多分わかんないんじゃないかな。
ああ、
うん、リロケーションの話がここで出てきた理由がわかんないっぽいです。
ああ。
Is it about migrating to a different device?
ああ。Yes,
自分のあれで説明しちゃえばいいと思うよ。
set the
Is it simply applying an image to the current edge device, taking an image and applying it to a edge device?
Yeah, yes, and yes, and set the you set the config to their image, and you relocate it.
The word relocate, maybe in, as we understand it, is removing something at one place and putting it at some other place. So it's not a copy, it's really a deletion. We delete it and we move it to another place. Is it what we're talking about?
Yes, yes. So,
小田さん、理解した、今の。なんか、リロケートって言ってる意味が、なんか、その削除して、どっか追加するっていうのはリロケートだから、それを言ってるのかっていうのを聞かれてるけど、ここで言ってる。
することをリロケートって言うんだけどって意味合ってるって聞いてますね。それと同じデバイスの中でアップデートとかアップグレードのつもりなのかとか、そういうところが多分伝わってない。
そうです。ちょっと私が言いたいのは、ちょっと言えないんですけど、言いたいのは、コンフィグをあらかじめ設定しておいたイメージで置き換えてあげると、置き換える方法もあるっていうのをここでちょっと示した僕は書いてるんですね。これがちょっと英語でちょっと出てこなくて。
日本語でもわかんないですよ。
置き換える、コンテナ、何を置き換えるんだっけ？
コンフィグを入れた状態のコンテナに置き換えてあげる。コンフィグを変更後のコンテナに入れ替えてあげるっていうのをちょっと言いたいです。
だからリロケートじゃなくてリプレイスメントじゃないの？
リプレイスメント。わかりました。
そうか、アップグレードとかの？
アップグレード
とかセットコン。だからちょっとリロケートっていう言葉が違うんじゃないかな。
He misused the English word. It's not relocate, it's upgrade or some.
Okay.
I'm sorry.
Yeah, thanks.
So I have a question. So I think this relocate container, you mean migrating a workload from one device to another device, or from cloud to edge, or something like that. So you propose to use Kubernetes for this?
Yes. Kubernetes is okay, but I think container commands can can do that. So I don't think Kubernetes is mandatory.
Okay, I'd like to see some more details about this.
Oh,
これの目的は何でしたっけ？なんか、そのKubernetesとかで、クラウドからデータをコピーするとか、そういう用途で考えてるんじゃないのかっていうふうに言ってるけど、それで合ってる？
そうですね。ちょっと違いますね。セットコンフィグは。
そのエッジっていうか、デバイスのコンフィグレーションを変えるだけというイメージだったら、なんかちょっとみんなの意識が違うから、もうちょっとなんか、一回、もうちょっとディテールを、今度説明するっていうふうにしたらどうですか？
わかりました。ちょっとそうですね。私も勘違いしてください。わかりました。Thank you. Thank you. I may misunderstand this. So we consider it and I explain it later.
Okay.
So you're gonna make new. It's more detail. Later, so and it's gonna explain the
sound is looping.
Yeah. Why? I'm not sure.
Just
ごめん。続けてください。
はい。Any other questions?
あれ言った聞いてなかった。また、再検討っていうのは、
There's an echo. On
yeah.
I also seem to have an echo here.
Sorry, Japanese. まだ私は答えてないところがあるって感じですかね。私ちょっと答えになってないですけど、
いや、すいません、ちょっと聞いてなかった。
大丈夫です。なんかエコーが入ってたから、なんでだろうわかんないけど、いいと思います。はい。なんか質問ないかって聞いて、なかったら続けていいんじゃないか。はい。
Oh, thank you. Any other questions?
All right. Then I think we can continue with the resource discussion because Michael has a short. He has to attend another meeting. So, Michael, maybe you can start your presentation.
Yes. Should I share my screen or my presentation?
Yeah, you can go ahead.
Can everybody see my slide? Or can anybody not see my slide?
I see it.
Okay, so this is some figures that we have been using for figuring how much system resources the container framework needs on target. I should mention that there are a couple of challenges with this because of, well, the way that some of these features are implemented, but I'll get back to that when I'm on the specific information. So just to set some preliminaries, this is measurements done on containerd 127 and runC 101. And it's been primarily done on 32-bit ARM devices, though some initial measurement seems like it's very similar on 64-bit. So I think that might need some further validation before I'm ready to commit to that. So to start, just talking about flash footprint. So these are some measurements done on one of our devices when talking about how much space the container runtime takes. So the biggest issue here is trying to figure out how much it takes once the file system is compressed. We use squashfs in our devices, and the difference can be quite significant. So even though if you list the size of the binaries, and they are reported to be in total about 45 megabytes, once we compress the file system image, it becomes 17. And that depends on what other things are in the flash as well. So I'm not really sure if there has been discussion regarding the file system compression to use for or not. So I'm giving both these figures. And that's kind of where we are working right now. There might also be some additional footprint for adding the container features to the Linux kernel, but that depends a lot on what your previous configuration was, and it's not obvious how much is actually used by the container framework, but it's a lot less than these 17 megabytes. So I've been rounding it off to about this. Any questions regarding these figures? So this would be the amount of flash required to store the container framework. No? Or? Okay, I will continue then. For RAM, the situation is even harder to measure properly, partially because Go is a sort of complicated language when it comes to memory management. It's both has its own memory management and it's garbage collected. The other problem is that the Linux kernel itself has a number of smart ways of dealing with memory. So even though the binaries, as we said, can be, let's say containerd, for instance, is about 30 plus megabytes, not all of that memory will be, not all of that binary will be stored in memory at once. The Linux kernel will page out parts of it. So when reading the memory usage for containerd, we are typically interested in the amount of heap space that it has allocated. And if we look at this slide, I've looked at one of the information files in the proc file system, and I would point you towards the anonymous memory that is in this case 16.4 megabytes approximately, and that would be more or less the heap space allocated by the process at one time. Now there is also some extra memory for sort of keeping the code, the executable in memory, and that seems to be changing a little bit depending on how long you've been executing the container daemon and how much is actually being paged out. Now it's hard to force this to happen, so I don't have exact figures for how much of the binary will be loaded at any one time. So this is something that we'll have to study under load and under certain configurations of the Linux kernel. But it seems like the complete residence memory size for the container daemon is about 36 megabytes. And then that scales depending on how many containers you have running. And it also scales briefly during operation because, again, Go has its own idea of memory management. So it pre-allocates some memory, and then it does garbage collecting over time. So when you do a deployment or change the configuration in any way, you will typically see a small spike in memory use, and then it's slowly sort of fading back to a persistent or steady state level. So from our measurement, it seems like the steady state memory usage when deploying containers is about 1 megabyte per container. And then there is the containerd shim process that's used to separate I/O from between the container runtime and the process, and that also takes about 1.5 megabytes. So that's the scaling factor for now. Again, it's highly tentative because the behavior of the Go garbage collector and the memory management can vary from Go version to Go version, and it's not dependent on the operating system standard memory management features. So yeah, it's a little bit tricky to be precise here. So any questions regarding these figures? I guess not. So a little bit then in summary, because this is sort of a work in progress right now. So we are estimating that up to about 20 megabytes of flash in the compressed file system is used for the container framework. And then the RAM footprint for the container framework is about 35 megabytes, plus on the upper side about 2 megabytes per container. Now, these are sort of frameworks that are being developed as we speak, so that might change if you go to a different version, and if you go to a different version of Go. What we kind of expect to be doing, though, is to look into the features of containerd and see if there are some of them that might not be relevant for using on Edge. There's plenty of plugins that you could think about disabling if you want to reduce the memory footprint or the flash footprint. Similarly, runC has there is a new container runtime primitive called crun that containerd has recently started supporting. It's essentially a C++ version of the runC command, and that is also significantly smaller both in flash and in RAM. So that might be something to look into if you want to reduce the footprint even further. What I think also is interesting is to see if there are ways to tweak the or to configure the Go memory management to be maybe slightly more aggressive with garbage collecting to make the transients slower. I wish I had a plot of that. I couldn't really make it readable, but it seems to be quite a long time, as in half an hour maybe, before a transient is completely garbage collected if you're unlucky. Now, the one thing that could be said for this is that the container runtime is not necessary actually for the containers to keep running. So if you are really, really short on system resources, you could actually shut down containerd and just have the shim and the container running. So one of the purposes of the containerd shim is actually to allow for the upgrade of the container runtime while the container is running. So the standard in and standard out and other I/O is connected to the shim and not to containerd. So you could kill containerd and the process will continue uninterrupted. Once you then start up containerd again, it will reattach to the shim layer and things will just resume as before. So those figures are what we are currently working on or working around. As I said, compression makes it tricky to guarantee what it will be. I mean, we could remove some other or change some other part of our firmware. It would increase or reduce the size. And for garbage collected application, obviously there is some extra things to consider as well. But yeah, are there questions regarding this? Fredrik, are you
Yeah. So do we have like a ballpark figure about base layers? So what sizes, if we want to, you know, have Ubuntu as base image, the size of that, and then on top, and then packaging OpenCV, reasonable set of OpenCV.
I haven't seen recent figures of the OpenCV work. I mean, right now my expectations for that is, the last time I saw it was around 17 megabytes for the entire OpenCV things. So that's the sort of the standard parts of OpenCV.
Can you repeat? 17 or 70?
No, 17, as in 17.
Yeah, I think that's probably without Python bindings.
Yeah, definitely. But it's also uncompressed. So if we're talking about compression, file system compression, that it's usually would probably be smaller. I mean, but that is indeed just the C++ parts. I mean, if we want to talk about the Python bindings, then you would also need to discuss the size of the Python runtime itself. So it's so I think the libraries, it's. I mean, what are we talking about? The Laravel API, or is there other APIs as well, or inference API, or other APIs as well?
Now the Laravel. I think Laravel is packaged as a separate container, right?
Yeah, but you still need the client library to talk to the service.
But I guess both of them are interesting, the size of them, both the container itself and the size of the. But I guess the library itself is really tiny in
yeah, but you also need then all the dependencies for the library to talk over dbus.
Yeah, true. You need protobuf, those things.
Yeah, for the inference, you need if we're talking about Laravel as an example, you need the G object and some dbus libraries. So I'm expecting, and this is just a complete sort of guess, that you will end up to having a base image that's maybe between 20 and 30 megabytes, and that's before compression. But I think that would not be a standard Ubuntu image or a standard, because you don't really need a lot of the sort of operating system level stuff. You'd essentially just want the libraries and support files, as in maybe the proto files and other similar things in your base image. So that is what I would sort of try to achieve.
Yeah, because the vanilla Ubuntu image is around 25 megabytes already, I think.
Yeah, I mean, there's lots of stuff in that you don't need in your resulting container on target.
Yeah.
Okay. So I don't know if you talked about sort of profiling these services. I think that would be an interesting task for somebody to actually consider, how to measure the memory usage of these things precisely. I mean, essentially, you would have to determine some kind of nominal load or standard load to measure the memory consumption under, because at rest they are not really that. I mean, they don't really do anything. But because of the memory management in Go, you kind of need to push the framework to do stuff. So you need to do deployment or reconfigurations or other operations to sort of exercise the framework. So maybe that's something to discuss for a future more detailed description of the resource usage.
Yeah, we haven't really discussed it, and I'm not sure if probably there is some other talk or something about this. I haven't seen anything on DockerCon or KubeCon or anything like that really targets resource management.
No, but I think it could be interesting for Unimatrix to define some kind of test workload for discussing system resources.
Yeah, so I guess we would have just run we will have an example application and run that one.
Yep, and then you can have some kind of time period it needs to run and some other kind of formalia around the application to make these measurements actually make more practical sense. Okay, anything else? I mean, I'm available by email and Teams if you have some additional questions about this later. Otherwise, I think I'm done. Yeah, maybe I think now Panasonic has a presentation as well on the resource. So maybe if you can stay until you have your meeting. I can stay for another 5-7 minutes.
Okay.
Excuse me, from Panasonic, can I continue the presentation? No?
Yes, please.
Yes, sir. Can you see my Excel file?
Yes.
Yes.
Well, I can see the screen, your web browser currently.
Web browser. Okay.
Now I can see it. Now I can see it.
Okay.
Thank you.
So, I also created this Excel file to make the estimation of hardware consumption of hardware resources. First, let me explain about this file. This Excel file has kind of two kinds of sheets for the estimation. The first kind is it's over here. The name of the sheet is 01.total. This sheet is to gather and estimate the total sizes of RAM and ROM required for Unimatrix. This sheet has the list of category. It's over here, and the major item for each category. It's over here, and I write down in the categories. First one is Unimatrix space and orchestration and inference, OpenCV and sample up. We may need some more categories, but so far I write these 5 categories, and for each categories we have some major items. For example, orchestration has as a candidate, it has Docker and virtual kubelet and privilege or some others, and as an inference is one of the major items is Railroad, and from far away, they present their own inference engine called Mindpool. It may be added. and the OpenCV libraries and its related programs, and its sample up is over here. Panasonic iPro created some of the sample applications and measured the actual consumptions of RAM and ROM. I'll show you later. And for each major item has individual other sheets, so that I can check them and estimate for each individual items. It's an example. This sheet is an example for Kubage, but I am not the specialist of Kubage, so the contents is currently fake. And first, here is the list of the contents of the Kubage, and the major content is listed over here, and their sub-contents should be listed over here, but it's not all listed. And write the description if you need it over here. And then after you listed up all of the items that consume the RAM and ROM, estimate, investigate the consumption of RAM and ROM. Here is a minimum RAM, RAM for minimum. Here is RAM for recommended, and ROM for minimum, and ROM for recommended. And it's, for example, it's a completely fake value, something like this. Yeah, all of the values are added to the over here. Here is a some product. I use some product function of Excel function. It's the some products of over here and over here, and added summation is over here around minimum. Similarly, we can get the RAM for recommend of total, ROM for minimum of total, ROM for recommend for total. I want to create this kind of sheets. Yeah. And so when you completed the estimation of RAM and ROM for each major items, copy these values onto the total sheet. Is Kubage item is over here. You write down the RAM minimum recommend, ROM minimum recommend, and its summation is will appear over here. And check, and next, after all of the items has been completed, we need to check and investigate which can be reduced and which needs to be reduced in sizes of RAM and ROM. Currently, these are very big, and I have an example. As I said, Panasonic iPro already created some of the sample applications, which is over here. It's called metadata over RTP sample application. It's over here. The content is written over here, and here is the sample apps base images in container. The consumption actual consumption sizes written over here, it's the actual sizes we measured in a Raspberry Pi 4. And it uses inference railroad. We use railroad. Railroad has some containers as listed over here, and it consumes like this. And this sample application consumes uses some other modules shown here, and it's the total number of the RAM and RAM required is up to about RAM is about 18 to 100 megabytes, and ROM is required and about over 600 megabytes. It's very big, so we need to reduce, especially for the base image. I found that especially the base images of the Linux is very big. It's based on the Debian 3, but when we build the images by pulling the existing libraries such as OpenCV Python, these might be one of the major big modules, and it increases the size of ROM. So probably we need, I think we need show the Unimatrix future users to show the sample of the more reduced sizes of sample base containers to easily develop and use for them, I think. Yeah, and then I wanted to, but like that, I want to complete making the list of major items as I show on the total. But we don't. I don't have enough time for today, so we have to continue updating this file. And but we cannot complete this without your helps. I need your help. So let's continue discussing on the regular meetings or on the mailing list about updating these files, this file. And final objective of this is to, my understanding is to reduce the sizes of the items in RAM and ROM, and finally declare the probably we need to declare the minimum and recommended RAM and ROM resources for some kinds of sample combinations as Unimatrix. Yeah, just for all for today. Any other question? Any questions?
It would be good to know which numbers that are fake and which are real in your presentation.
Okay. I updated this file. Yeah. Which one is true and which ones are fake? And share. Yeah. Yes. Thank you. We might have a presentation. Probably Kevin has a presentation of CubeEdge. He's a specialist of CubeEdge, and probably he knows about the current consumption sizes of RAM and ROM. Could you share if you know about the sizes? No? Kevin is absent.
Yeah, I think probably it's joining later on.
Oh, okay. Oh, thank you. Okay.
But yeah, Access can update the things we had from Michael's presentation, the size of containerd and runc. Also, we have a ballpark figure about the OpenCV size. I think it's like 17 megabytes of ROM, but that's uncompressed flash. So the sizes that you are listing, it's uncompressed size, right?
Yes, uncompressed size.
Because it's quite as you saw in Michael's presentation, it's quite a big difference if you compress it. Like if you're gonna include it in your image, it will be reduced a lot when it's compressed.
Okay. Okay, we'll try.
But yeah, so just so that everyone knows, maybe you can list that it's uncompressed sizes when you just clarify that in your presentation.
Yes. Okay. Yeah, I continue investigating about that. Yeah, thank you very much. And any other questions? Okay, thank you very much.
Thank you. So, do we have any update from Hikvision about resources? Have you looked into this? Because I remember last time when we were planning, you wanted to do some presentation. Maybe if you don't have an actual PowerPoint, you can just talk about what you have measured so far. Dora, are you listening? Maybe
I have just pinged her on WeChat. I don't know if there's an issue with connection or whatever.
Yeah, I saw she unmuted, but I couldn't hear her, so maybe she's got problems with audio. Hello, Dora.
She's responding to WeChat at least.
Yeah, I saw
Give me a moment.
she's unmuted, but I can't hear anything. So maybe she's got some problem with the microphone.
Sorry, I got the I got the wrong person here. It's not Dora I'm writing with. Sorry, just give me a minute.
All right.
Perfect.
And sorry, I'm Leo from Hackathon. About the RAM and ROM estimation, can you hear me?
Yeah, we can hear you.
Okay. We have the same result with as access, so we don't have any new comment.
Okay. Do we have any other updates regarding resources? I think Dora is trying to connect again.
Yes, can you hear me now?
Yeah, I can hear you.
Oh, sorry.
Yeah.
My colleague has introduced. We have the similar result with Axis, and about the API, I will the resource of the API that it uses. I will introduce it later in my presentation.
All right.
Okay.
So I think if there's nothing else on this topic, or if there is something else you'd like to that's not in the agenda, otherwise we're going to take a break until 12. Then we're going to start with the presentation from Axis, from Hassan, about video API. So you can go grab a coffee, and then we'll resume in about 15 minutes. Okay, we're back. So next presentation is about zero copy using OpenCV. Hassan,
Sure.
are you ready to present?
Yes. So let me share my PowerPoint. Can you see my PowerPoint presentation?
Yes.
All right. Thank you very much. All right. A very warm hello to everyone. My name is Hassan and I work at Access Communication. And I will present zero copy with OpenCV capture today. So before starting, I would like to walk you through the agenda, how I'm going to go through it. So I will start off with some of the very fundamentals, basics. What is Capture API? I'm pretty sure most of you are already familiar with it.
Can you wait? I can't see your presentation. Oh, now I see it. Sorry.
Can everybody else see it as well? I need confirmation from one or two.
Yes.
All right. So shall I continue?
Yeah, fine.
All right. So, like I said, I will start off with some of the fundamentals, like what is Capture API and why we opted for OpenCV. What are some of the potential benefits of using OpenCV on the edge devices? And then I'll walk you through some of the zero copy requirements that we have implemented in the example, followed by a few optical properties that you can extract using the sample code. And I'll give you a brief demo regarding how to run the sample code, followed by question answers and feedback from you regarding what should be done further. So starting off with the Capture API, as you know, the API provides access to video capture capabilities of the device, and it intends to serve as an industry standard for facilitating analytics-based applications. One common example of it is running machine learning models on edge devices for scenarios like object detection. And why we have chosen OpenCV. OpenCV is an open source computer vision library, and it already has a very well-established developers community. So Access would like to promote the use of OpenCV with our cameras to give developers a more state-of-the-art developer experience. And since the community is already there, so it's much better to use the existing community and possibly upstream the code examples as well regarding how you can use OpenCV with Access cameras. Another important aspect of OpenCV is the licensing model it has. Since it is based on BSD, which makes it very convenient for the businesses to add value-added services on top of that and make business out of that. So it's a win-win for everyone, for the community, for the companies, developers contributing the code. So making those examples available would certainly facilitate the community and the developers and the companies as well. Moving on to the requirements that have been considered and implemented for this example. The first one is, of course, the zero copy file descriptor backed buffers to facilitate inter-process zero copy. It supports the limiting number of in-flight buffers. You can set the amount of buffers you can have. Apart from that, you can get frame per second. You can set the frame width, height, and then some of the basic image transformation. Some of the discussion might overlap with or technical discussion that will be held at the end of the session. So I would like to talk a little bit more about the native formats. And since we are building a community now, might be a good idea to start talking about what are the formats the Unimatrix should support, and if we should aim at standardization towards certain image transformation and so on. So that would be an interesting discussion to hold. And then the next thing is you can also extract image properties such as exposure, gain, focus. But I suppose that would be very hardware dependent. And it would be interesting to talk about possible use cases for those properties as well, if we can make them mandatory, or how do we want to move forward with that? But I'll come back to it later in a while. So I'll move on to the sample code. So the sample code is available on GitHub at the moment. In order to run, I'm running it on an Access camera, and Docker Desktop is installed, and Docker Daemon is running on the camera. So I'll take you to GitHub where the sample code is publicly available. Can you still see my screen with the GitHub?
I'm seeing the presentation right now.
All right. So probably I'll have to. I can't see sharing a desktop. Yeah, you should be able to see anything. Okay, I might have to switch between screens all the time.
Maybe it's easier if you share your desktop, I think. Yeah, now we see it.
Yeah, but I can't see that option. Generally, I do that. So now I'm switching between two different screens. Anyways, so continuing with that. So here is an example available on GitHub. It has a very well-structured README file available for the developers to try it out to see how it works. So I'll walk you through it. So the capture CPP, that's the file that captures certain properties and implements. This is the sample code that implements the zero copy implementation. And then you have the Docker file available with the tool chain to run the example. And then in Docker Compose file, you also have the latest image of the example. So I'll switch over to Visual Studio Code, and I think I will have to share Visual Studio Code now. Not really sure. All right, so it's presenting. So hopefully you can see my Real Studio Code window now. So it's the same example that you have just seen on GitHub. I've cloned it and I'm working locally here. So in the Docker file, you could see the toolchain and the API images that are required to build the example with Access Camera. I must mention here that some of these two images are available on Docker Hub at the moment, but they are private for now. But they will be available for Access Early Partner Access Program sometime very soon. So that will be made public as well. And then if you look at the sample code that I wanted to show you for the zero copy implementation. So here you see the OpenCV backend, and then if you scroll down, here we are defining the buffers, 2 buffers and 30 frames. Then you can start streaming the channel. Let's say if you have multiple data input sources, you can choose which one to capture it from, and then you're setting the frame width and height. And then these are some of the formats that you could. Basically, we need to work through it and understand which ones would be more useful. I think the more native format for Access cameras will be NV12 and Y800. RGB3, it has a penalty. You have to convert that. That's another discussion point we can take later. And once you have that, you can start extracting actually the zero copy parameters, file descriptors, offset, and size associated with it. It is also important to note that once you capture the stream, you cannot modify stream properties after that, because it would be quite expensive read and write operations to do after that. So yeah, here then finally the example is printing the frames, the file descriptor attached to it, offset, and the size of that. So if I further go down, you can also extract optical properties from the camera, such as gain, exposure, zoom, focus, and f number. So I'll try to run this example and show you how does it look like if you try to run the image. So I've already pulled the images, so it should be relatively quick. So I'm going to use Docker compose command, and I have a camera set up. So I'm going to go ahead and try to run it. There we go. So like we said earlier, we went for the 30 frames, and then you can also limit the in-flight buffers as well. So here you see the frame and then the width and the height, file descriptor attached to it, the offset, and in case you want to send this file over a network, it would be handy to see the file size as well. And if you look further down, you could also check the captured frames per second, and then some of the optical properties can also be visible right here. So that's the example you have currently available, and which implements some of the fundamental basic scenarios. There will be a further implementation of that feature set 2. I'm not really entirely sure what exactly will be included in that, but yeah, this will be extended, of course, internally in the next release. So let's see if I missed anything. Okay, so I'm gonna switch back to my presentation again. Yeah, so that's how you run the sample code. So takeaway from that is the sample code is available on GitHub. You can, and the SDK required to build that example will be made available sometime very soon. So that information can also be seen on the GitHub page. So then it takes me to the question answer and discussion points. The first is the color space, of course. Since Unimatrix is a community starting to grow, so it would be an interesting question for companies in the community if we would like to standardize around a specific color format, or do we want to set any requirements on what are the mandatory formats and then what you can't have and what you can and so on. For some reason, RGB became the industry standard. I'm not entirely sure if anyone knows exactly why RGB3 and not someone else, another format, but it has a conversion performance penalty. So we might want to keep that in mind. So that's one discussion point open. And then the second one is you saw a few optical properties that were displayed in the example, like exposure, gain, and focus, etc. So do we as a community see use cases for these properties as well, or are we interested in making some of these properties as default properties? So with that, I open the floor for questions and discussions. Thank you.
I have a comment on the formats or the color space support.
Sure.
I think that the reason why RGB is the input format for many neural network architectures today is that most of the work has been done in the academic world, and no one have really thought about from the start to run inference on the kind of camera devices that companies like Axis or others are manufacturing. But I think if we look into real use cases, one good example is the use case where you on the camera device run a detector, and when you detect objects in the image feed, you want to encode the object ROIs as JPEG images. In that case, you would probably want to load an NV12 of an image in a NV12 format from the video or image API, because that's the input format to the encoder as well. So you would probably not want to load an RGB image, feed that into the detector network, and then convert the RGB image back to NV12, because the NV12 is likely also the output from the scalars of the camera SoC.
I suppose, like I said, now that we are in a process of starting a new community, it would be an interesting to make a conscious choice in terms of what should be some of the native formats to avoid getting performance penalties. So this is a discussion worth having in the technical board meeting, I suppose, with all other companies.
Yeah. I think that if you only the kind of devices that are relevant here, that do video encode and decode, the image scalars and so on, all these devices primarily work on NV12 format. There are, of course, other formats that some of the platforms can work with, but that are the primary formats. I think it's only for only the neural networks, the common neural network architecture that take RGB as input.
I wonder if we have any comments from some of our Chinese collaborators, Huawei or Hikvision. Do they have any feedback on that?
Yes, this is from Huawei. I'm not the expert of such color format, but I know that our product will use the YUV 420 SP format. That's really very common in our product.
I think NV21 is quite common in China, right? So it's
no, 420.
Yeah.
Yes, 21. Harry, your chip usually provide 21 only.
NV12 and NV21 is common encodings of the 420 subsampling of YUV data.
Sorry, okay, repeat your question.
I just commented on that the NV12 and NV21 formats are common encodings of YUV data subsampled as 420.
Yeah, they are quite similar, but I think NV21 is native for high silicon, right?
Yeah, I recall that too.
All right. Do we have more comments, questions?
I guess, Yoon, you will have another update about in Laurod how you can do the conversion there.
Yeah, I will get in a little bit into that.
So which means you could do, you don't have to do the necessarily support or do the color conversion before the inference.
I think it's a good idea to pair up the YUV to RGB conversion with the CNN processing, because it's quite specific to that use case.
Yeah, I think we talked about these formats already in December, and I think these 4 formats were the one we discussed back then as well. So I'm not sure if we can. As I said in my talk before, I wanted to form this video working group that will kind of specify the mandatory requirements for the formats.
Yeah, sure. I mean, I just wanted to bring it up to the table so that we can discuss around the table.
Yeah, of course. It's also, I mean, for the technical board meeting, I think at that meeting we should only we could have the discussions before that and only take decisions on those kind of meetings. Okay, are there any other comments, any other formats, or can we talk about the properties?
Yeah, is there any member who could think of possible use cases with these properties? Would that be useful in a specific case?
I think they can be very useful for some kind of applications to kind of, if you know the focal length and things like that, you could try to calculate distances and sizes of stuff.
Sure.
So I think the optical properties are very interesting for some types of applications. But on the other hand, there may not always be possible to have those. If you have a lens that is a manual focus or something like that, you have no idea what.
That's true. So that would be very hardware dependent then, sure.
So it can never be mandatory, but
good to have.
It could be similar to in OnVIF, that if your device is has an automatic lens or something, you must provide these properties. In OnVIF, we talk about mandatory, conditional, and optional. So this could be like a conditional. You need, if your device has an automatic motorized lens, then you must support this property.
All right, so if no one else has any comments or questions, I would like to give the mic back to Frederick.
Hassan, just
sorry, wait a moment.
Sure.
I wait.
Leo, go ahead, Leo.
Go ahead.
Oh yeah, thank you. I'm Leo from Hackathon, and I have a question about the euro copy. So you explore a buffer as a file decryptor. So you need a driver to inside the kernel to implement this.
Not sure if I follow your question.
So your solution is about your euro copy. Your solution is explore a buffer as a file decryptor, right?
Yes.
So how to do this? You need a driver inside. You need a driver in kernel to do this. I mean. Right.
It doesn't have to be in kernel. For our platform, we have a user space service that memory maps these buffers to and provides them.
So you means you have a you have a server in the user space, and to convert a buffer into a file decryptor, right?
Well, the memory is actually allocated by the kernel.
Yeah.
Right. Maybe you can elaborate a little bit.
Yeah, we have different methods for allocating memory buffers. One simple way could be to allocate in user space, because as Frederick said, we have one central video service in our platform that has the responsibility to dispatch video coming from kernel space, from a hardware encoder, for example, or from a scaler to different client applications. And one simple way that service could allocate buffer memory is through the use of memfd create, for example. Are you familiar with that call?
MFD create.
memfd create underscore create. So that's a way to allocate memory and get the file descriptor referencing that memory back. So in that way, you have you could look upon it as a memory mapped file in a RAM backed file system.
Yeah, I know. So so I will look into that later. I have another question. If you exploit a buffer as a file decryptor, how the buffer will the file decryptor will be will show between the wait a moment. If how to synchronize with the read and write operation with between different process. So if a productor create a buffer and transport it to another process like customers, so how do they synchronize read and write operation?
That's a good question. I mean, I'm not entirely sure. I know fairly well our underlying video service and how that works, but I don't know the exact details of how our OpenCV implementation works internally.
Aren't the buffers read only? You can't really modify them. So it's intended for consumption. I mean, one producer, multiple consumers. So it's not intended for someone to modify a buffer. I mean, this is basically images that normally it's encoded images, but you can read also raw images. So it's just a multiple consumer and one producer.
But producer should know one she could release the buffer, one and one
okay. I see what you mean now. Yeah, that is handled by the kernel. So when the last consumer is closing the file, it's automatically released. So this is just a standard file.
Yeah. Oh no, I know.
Yeah, I think the question might be how can I guess that there must be a pool of buffers, and how can the underlying service know when to recycle the memory buffer sent over to client with OpenCV? I don't know about that.
Yeah, I wish we had Daniel here. He could probably answer this, but I guess you get a notification when the last consumer has closed it, and otherwise, as long as someone has it open, you can't really reuse the buffer. So if one client is misbehaving, you will end up with all the buffers full.
Yeah, that's possible.
So in my talk earlier, I had a suggestion of doing a common Unimatrix driver for OpenCV, so that would handle these kind of things. But you still have to provide a backend for your hardware to provide the file descriptors. But I'm not really sure if my idea really flies or not. I would like to first do a proof of concept, but I think we will probably be able to work. So my idea is basically to use Redis as an interface towards the OpenCV driver, and then something else, a backend will feed Redis file descriptors or these capture properties like timestamp and things like this.
Yeah.
Is Redis able to handle file descriptors and to receive and transmit file descriptors to and from clients?
It's just a number, right? File descriptor.
Yeah, but in case there are different processes involved, the number would mean different things to different processes.
I think we already did a proof of concept with Redis.
Okay. So it's likely solved in that case. Yeah.
I think it was solved on this watchlist demo.
Yeah.
So my question is somewhat related, and maybe this was discussed in December before Focal got involved in the project, but in my experience, capture is often sort of strongly connected to transcoding and transport. And so what you see a lot kind of in the wild as naive developers start building out their applications is GStreamer starts showing up pretty quickly, especially for networked operations. Not so much against local hosts, but certainly against remote hosts. And so you end up with a kind of a funny design challenge, and that's, do you let GStreamer be in charge of scheduling and effectively build your application as a GStreamer node, or do you embed GStreamer inside the application and let OpenCV be in charge of the sort of the outer loop of frame capture and processing? And there's never a good answer to this, and I'm just wondering, whether or not thinking about capture and color space in terms of the greater operations of transcoding and transport maybe is an important thing to do, and whether or not people have opinions or similar experiences with regard to the connection between capture, color space, transcoding, and transport.
Are you thinking of, however, such a pipe? If we take GStreamer pipeline as an example, are you thinking of, however, the application would run that pipeline, set up that pipeline and run it, or if someone else should run the pipeline? Could you elaborate a bit more on your concern here?
Yeah, I guess you see both models, right? So now, granted, we're moving into a sort of a new, with Unimatrix, we're moving into a new approach to architecture, which is a containerized architecture. But nonetheless, within individual containers, you're going to certainly see a proliferation of approaches to the color space, transcoding, and transport problems, right? And there's one model in which your OpenCV application is just a node in a GStreamer pipeline, and that model is well supported. There are examples of it in the GStreamer docs. There's even though GObject is terrible from a developer's perspective, in my opinion, there's a bunch of good stuff to get you started under that model as a naive developer. The other model is that OpenCV kind of owns the key frame capture event loop, and then GStreamer is subservient. Basically, frame capture happens, the outer loop of frame capture happens, frames get processed and then forced into a sort of a standalone GStreamer egress node within the OpenCV application. And so I think it behooves us to be opinionated about this, because it can quickly kind of turn into a knotty mess. Both approaches have their problems, and it's not clear to me how we want this to work, given containerization as a kind of a base assumption here. Do we think about standing up a GStreamer application in its own container for egress to the network, for transcoding and transport? If so, GStreamer I don't think is going to play nicely with zero copy. To my knowledge, I haven't looked at it in detail in probably 4 years, but I think the issues of color space, transcoding, transport, and capture are all strongly connected in my experience.
Yeah, I think we have actually, I think we have been discussing about the possibility to support graph-based frameworks like GStreamer in order to build these kind of deep learning-based analytics applications. We have been discussing both the approach of having a service setting up and running the GStreamer pipeline on behalf of an application, and also letting the application run, put together all the elements, set up the pipeline, and run it. But I think that approach, where the application sets up the pipeline and run it, is the better one, because it's the only approach where you really can extend the pipeline with your own elements. It's very hard. It's very hard to inject inject element implementations into a service running the pipeline from a security perspective, I would say, because the service wouldn't know anything about the contents of these elements and what they will try to do.
Yeah, I agree. And then you could crash the whole service from an app also. So it's not a good design. But I guess Brian, from your question is if we should kind of include these frameworks in the design, or if it's up to each application to solve this.
Yeah, I guess that's the question, right? So I think one approach would be for us to get very opinionated and say that, kind of say how transcoding, captured transcoding, and transport should all, work together, specifically around zero copy, right? Because, zero copy is important certainly between containers within the operating system running the application, but zero copy is also important for network egress, right? So there's another definition of zero copy, sort of at least the context that I'm more familiar with zero copy in is is the network stack, right? So how efficiently can the application take frames, pass them to kernel space, put them on the network? It seems to me that there needs to be some unifying principles here, especially given that we're talking about color space changes. That the next step is, from there is transcoding and transport, right? There's just a natural progression of kind of the stack of capabilities from capture out to the network. And maybe we don't need to be opinionated about it, but I think you're going to end up with a lot of inefficiencies if every container is solving the network transport problem in its own way.
When you mention transcoding, what are you exactly referring to?
Potentially H.264 transcoding, wrapping in RTSP or similar real-time protocols, stuff like that. The stuff that GStreamer kind of just handles.
You're primarily thinking of more streaming applications rather than analytics applications in this case.
Yep.
All right.
Yeah, those kind of use cases we have not really talked about. The main focus so far has been analytics applications that consume video or audio and produce a much smaller result that you can like metadata, some kind of metadata or an event or something like that.
Yeah, that's a fair design constraint. But I think if we're going to open the can of worms on color space and capture, you very quickly beg the question about transcoding and transport.
Yeah, I mean, for Axis, we're already using GStreamer, but I think for a lot of other companies, they are probably using different frameworks. But yeah, we have started to look at it but we haven't really talked about it in this forum yet in standardization. We have talked about it for our own platform, but not really here. Are there any other opinions about, is this something we should look at to standardize around scheduling mechanisms and like frameworks for really application, how you build your applications and so on? GStreamer is also quite big framework with all the plugins and stuff. Are there no more comments? Then I guess we can move on to Inference API.
So is it me then?
Yeah. Next point is update about Larod.
I will try to get my presentation up here. You see it?
Yep.
Great. So hi everyone, I'm John Iverson. I think that some of you have heard me go on about inference, CNN inference infrastructure before in December. Now I'm just going to give you a quick update on what's have been going on since last time with Larod, our inference engine that I presented in at the hackathon in December. So the news are that we have added support for new hardware platforms. We have since last time we have added support for the Google Edge TPU. We have also added support for Umbrella CV Flow. So we are now running it on Umbrella hardware. And we have also added support for running TensorFlow Lite with the GPU delegate, and we have actually done it primarily in order to accelerate Larod on host systems, but it should be possible to run on embedded systems as well. You need OpenCL plus OpenGLES. That should be possible to run on many different kind of GPUs. What we have done as well is improvements to the Tensor construction API. So it's now easier to get the information from the service about what the loaded graph or model expects in terms of tensor format. So that can be probed by the application to some extent. I think that's the main news since last time, and I will also give you a quick update on our roadmap for the future. We are actually in the middle of process of adding support for image tensor pre-processing, and with image tensor pre-processing, I mean primarily these three operations. It's crop, scale, and YV to RGB conversion. And we have been we were discussing about the color spaces and the conversions a few minutes ago, and we think we have added this. We are adding this to the Larod inference service because it's in practice. In practice, this kind of pre-processing is very tightly related to the process of performing inference, and we think that converting from YV to RGB is it's closely, the need for that is closely related to the inference process. So what we plan here for the future is that we plan to do some work on improving the buffer, the tensor buffer handling, because we think today we make in some cases we make copies of data, and we will try to optimize that away. We are also looking into leveraging the kernel, Linux kernel DMA buff framework as well, because it's it gives us really nice support for passing buffers coming from one hardware device over to other hardware devices, and it's possible to by using the DMA buff framework in the Linux kernel, it's possible to export buffer handles from one driver in the form of an FD and import it back into the kernel space again in a different in another driver for a different hardware device. So that is one thing that we will look into during the coming weeks. We are also planning for a move to GitHub. You know that the Larod source code is currently available on under the Unimatrix project on GitLab, but we are planning to move it to GitHub. One feature that we are thinking of as well is to add support for chaining multiple jobs together, as in this example below here, to be able to issue one job containing pre-processing, CNN inference, and post-processing as one single request to Larod. That is one thing that we are thinking of for the future. We are also thinking of adding support for Android NN API and NVIDIA TensorRT as well. So this is actually all I planned for today. So I think we are a bit behind schedule. So maybe we can gain back some minutes here. Any questions on this?
Which devices are you? Which NVIDIA boards have you tested against so far, John?
Sorry, I didn't hear your question.
Which NVIDIA devices are you currently testing against? Or
We are not testing on any NVIDIA devices, except for host GPUs. Okay. We don't use any NVIDIA devices in our own in our embedded products today. So if you are thinking about the last topic here about NVIDIA TensorRT, it's more. I think it's more for our purpose. It's more for accelerating the host GPU when running on host GPUs, but it could also be of interest for people that want to run on NVIDIA embedded platforms like the Tegra TX 1 and 2, for example. Any other questions or comments?
For the color conversions, I guess you have a dependency to, is it libyuv or what are you planning to?
I could elaborate a bit on that. We are planning to add support for different backends there. So libyuv would probably be one backend, and that is the most portable one because it runs entirely on CPU. So that could be one backend. But we will add support for using for example, the Ambarella pre-processing library. that are able to accelerate these operations. I think that we will likely do an OpenCL implementation, for example, that could be used on multiple platforms. In case one will want to run on, for example, high silicon platforms, that would in case require an implementation of a pre-processing backend for high silicon chips, and that would have to, in that case, I think it would be reasonable that such a backend is capable of converting from NV21, if that is the output format from the high silicon platform. So I think we need to think about different platforms with different capabilities here.
So there will be some kind of backend API, I guess, that if you want to use a different hardware platform, you would have to write a backend for that one.
Yeah, so it will work. It will be designed in the same way as for inference backend. So when we, for example, when adding support for umbrella platforms, we would have to implement one CNN inference backend using the umbrella NM control libraries that are capable of accelerating CNN inference. But we would also, in order to leverage from the umbrella pre-processing acceleration, we would have to implement a pre-processing backend as well, using the umbrella vproc libraries that can accelerate that process as well.
So since this is a collaboration project, right? So where would you say that you want some external help to get things moving on some of this?
Yeah, it's a really good question. We are not entirely set up to accept pull requests, but I think in the meanwhile that we need to, I think we will need to take discussions case by case, and I think we will have to get in contact with other teams external from Axis that would like to add functionality to Laravel. But I mean, I think that the most likely part would be where it's relevant for others to add functionality to Laravel would be different backends for different hardware platforms, I would say. But it could be a possibility that someone lacks features from the framework as well.
Yeah, maybe Hikvision has some comment about that. Would it be, I mean, for example, for the Umbrella backends, have you talked to Umbrella about providing, maybe supporting on those? I mean, providing code to Laravel for that?
We haven't been discussing them providing implementations for their platforms yet, because we did it. It didn't take us that long to add these backends because it's fairly simple. But what they have been doing lately is that they have released the libraries that Larod calls into under Apache version 2 license, so that we can make these backends publicly available later on.
Okay, thank you. Are there any other comments?
Hi. We have one question regarding your Larod framework. As you said that you currently you don't accept any poll questions inside of Unimatrix, and so our question is that how you can keep every hardware platform up to date inside of your Larod platform. It's everything decided by Axis. You work out your own plan, or there's some other approach we can share, or we can do something together. So I'm still not very clear on that point.
I see what you mean.
Yeah.
Up until now, Larod have been developed entirely by Axis, and one thing that we have been waiting for is a formal decision within the Unimatrix project to use Larod as an inference engine. If Unimatrix comes to such a decision, I think that that means that we get into a different situation where we need to set this up as a real public open source project where we can accept pull requests from other companies like yours. So, but I think we're not really there yet. But in case the Unimatrix project comes to such a decision, I think we need to do that. Is that an answer to your question?
Yes. And I don't know, inside of Unimatrix, are we going to make a decision on this, or is there any planning we're gonna talking on that part? Because I don't know, from our part, one concern is that as more and more hardware platform coming out into market, is there any occasion will happen that if Axis take lead of Larod, and then if some kind of hardware platform Axis doesn't use for your product hardware, so how it will come? I mean, inside of Unimatrix. So I don't know if that will raise some issue or something like that. So I don't know.
I mean, yeah, even if we would not, it would be possible as long as the Larod source code is available to you. You could definitely add you could definitely fork that and add support for different platforms, but then it would be a choice by you to upstream that, so to speak. But that of course demands us to accept pull requests. But I mean that we need to set up that infrastructure in case the Unimatrix project comes to such a decision.
Regarding
okay.
Regarding the decision, so I put on the technical board today that we can take a decision about making Lara the official API.
Yeah, so I would say it's quite similar to if you are using the Linux kernel and you have a device that is not supported by the upstream kernel. You will add support for, you will add a driver for it locally, and build it locally. So that would be in case the platform is not supported by Lara upstream. It would anyway be possible to add support for it local. Okay, I think that was all questions and comments. So thank you very much for listening and asking questions.
Okay, then we hand over to Hikvision for their presentation.
Yeah, my colleague will do the presentation. Yeah.
Can you see?
Yes.
Yes. Okay. My name is Feng Guang. I come from Hackathon. Today my topic is about AI inference. Now let's begin. And the above graph is the general process flow of inference. Optimized model and pre-processed image are inputted into the inference library.
We don't see your screen now.
Yeah.
Yeah.
We saw it before,
看不
then
到
it
你的
disappeared.
屏幕。
Okay.
Yeah.
你把这个最小化，把这个最小化试一下。
要看一下，这没有显示。
这个不能最小化吗？这个上面不是也有个最小化啊？这里。
这边是屏幕共享不就可以了吗？
你直接就是共享的时候选择你那个 PPT 应该是可以的呀。你选择就是点共享，然后选择自己的 PPT 啊，可以了。
能看到吗？
好了。
可以看到吗？
可以了。
可以看到了是吧
？It's good. It's good.
OK。Now let's begin. The above figure is the general process flow of inference. The optimized model and the pre-processed image are imported into the inference library. And in order to achieve the goal of our agents, we need to pay attention to the following points: standardization, custom, and security. What we focus: image pre-process, model format, and model encryption for security, and the last one is the custom layer standardization. First is about the model format. Now the supported model formats are different between different runtime. So the current architecture cannot specify any runtime for any front-end model. So we need a model or unified model format, that is IR, intermediate representation. The benefit the IR bring for us: first, enhance the interoperability of neural network framework. Second, we can specify any runtime for front-end model run on any hardware platform to load support. Now we recommend the ONTAR as the IR, which is now widely used in the deep learning area. Next up, image pre-process is an important part of AI inference. So we want to propose a standard in this aspect. We have two standardization about image pre-process. The first is the interface about image pre-process. We have two solutions. The first solution is to choose OpenCV interface as the standard interface, such as the CVDR resize, CVDR warp affine, CVDR CVT color. The second is we can define a set of interfaces by ourselves. The following picture is the interface we defined. It has a file interface, including get memory, create, process, get version, and release. We also need to unify the operator specifications, such as the type both of input and output, and the image format, and so on. The second is about model encryption standard. There is a possible application scenario. Hardware platform A develop inference library A, an algorithm vendor develops model B and encrypt it and upload to the model tool. User C download the model B and use inference library A to load model B. So the inference library A needs to decrypt model. If the model is not encrypted, it will be exposed on the release and download path and is relatively easy to be incepted for use or modification in other places. So we need to have a model encryption solution. And now we have a solution that is secondary encryption. First, use the symmetric encryption key to encrypt the model file to get the encrypted model. Then use the asymmetric public key to encrypt the symmetric encryption key, which is used to encrypt the model file. The finally encryption model consists of two parts: encrypted model and encrypted symmetric encryption key. Then when use the encryption model, the user needs to obtain the asymmetric private key authorized by algorithm vendor B to encrypt the encrypted symmetric encryption key. Then use the symmetric encryption key to decrypt the model. This is the secondary encryption solution. There are many ways to authorize the private key. Different way of authorization should be adopted according to different application scenario and security requirement. If our main proposal is to solve the security problem in the model publishing and download path, we can authorize the private key directly to the device vendor. Next up, before introducing the custom layer standardization, let's review the proposal about runtime unification at the last meeting. The standard process of runtime is shown in the figure. It has several steps, including pass model, create inference, prepare input date, and forward and release. Now I will introduce the runtime interface standardization and the custom layer standardization based on this proposal. First, I will introduce the inference interface of the runtime. It has 9 interfaces, including get model mem size, create model, get mem size, create, process, release model, and get config, set config. This is the interface of inference library. At present, many algorithm vendors have their own custom requirements for the implementation of neural network OP, such as the YOLO proposal of network YOLO. Lalod needs an architecture and corresponding access standards to support custom layer. User defines a custom layer according to the standards Lalod provides and embedded into the Lalod runtime. In the previous session, we have already standardized the inference interface. Now we need to provide a set of custom layer interface that can be embedded into the main process. It has six interfaces. First, layer get model mem size, which calculates the model memory required by the custom layer. Second, layer create model, which create the custom layer and load the model. The third, layer get mem size, which calculates the algorithm memory required by the custom layer. Layer create, which creates the custom layer handle. Layer forward, which is the custom layer forward function. And the last is layer reship, which is customer reship function. Finally, since the architecture of Lalod is client server, the resource of client and server are isolated. So Laload is required to have custom layer registration and custom layer library loading solution to support custom layer. We have two solutions. Solution one is that Laload load the custom layer library dynamically. Custom layer is provided as a dynamic library. Solution two is that the custom layer run independently in the process and communicate with the main process. We recommend the first solution. That's all. Thank you.
I have a few questions on this. At first, I have a question on your intermediate your proposal regarding intermediate to define an intermediate representation. I see that a consequence from that would be that we would exclude support for any platform that does not support online code generation, like for example umbrella platforms. There are also a number of Flash-based accelerator architectures that are coming up that are not able to generate code online, so that are dependent on an offline tool to generate the executable, the model executable.
What is your?
Sorry.
What is what's your main question?
I'm just it's just a comment on the consequences from defining a common intermediate representation that would be the main entry point for models that are going to be executed on Unimatrix devices. My comment is that I think it would exclude support for any platforms that are not able to generate executable code online or on device. Such platforms that depend on offline tooling to do that.
Yes. We proposed the IR intermediate representation. The reason is that now in the Laload, the front-end model format is associated with the backend runtime. So if we want to run a front-end model, we need to specify the runtime which support this format.
Yeah, I mean, if for example, if you're interested in supporting an intermediate format like Onyx, one solution could be to add support for the Onyx runtime as a backend to Laravel. We have actually thought about doing that.
Yes, we should support OwnChat runtime. There's another reason is that we want to all the runtime support the format OwnChat. So we have a unified model format, and we can specify any runtime for the.
Yeah, but I think that what I'm trying to say is that if we do that, if we define for the Unimatrix project, if we define one common intermediate format as the common entry point to Unimatrix devices. That would exclude support for platforms like Umbrella, for example, that depends on offline tooling to convert from such an intermediate representation. Because many device manufacturers support these kind of formats like Onyx through the use of offline tools. The offline tools accept the Onyx formatted models as input and produce a hardware dependent or platform dependent model executable as output that can subsequently be loaded onto the device and executed there. And I think that, for example, Umbrella is it's a quite common platforms among IP camera vendors. I don't know about high silicon. Is it possible to generate the executable on device for high silicon, or are you depending on an offline tool for that?
Now, more and more time is planned to support the internet web. So I think in the future, the Onyx will be the common model format. Most of the runtime may support this model format.
Yeah, but I don't think it might be a common format, but I don't think it would be the only format.
If in this proposal, I mean, we want to find a unified model format. The Onyx is one choice. We can choose another one more suitable.
I agree that I think that Onyx as an input format and through the support of the Onyx runtime, I think that has a clear role to play here in this infrastructure. So I think, I mean, it's definitely possible to add it as one supported input format. In the same way as TensorFlow Lite, for example, is a supported input format to Laravel currently.
TensorFlow Lite.
Which kind of devices do you target through the Onyx format currently? Which hardware platforms do you target through that?
Do you support high silicon hardware with the Onyx model, or is it only for server architecture?
I think that for the Onyx format, I think for the Onyx, as far as I recall, the Onyx runtime supports CPUs, GPUs, and custom Intel accelerators. I don't recall that there are.
Yeah, that's what I remember. I think
they have. Support.
I think Milan mentioned they have thought about adding support for Umbrella, for example, but they haven't found a use case so far. That's what he said.
Yeah.
Mm-hmm. I think for the compatibility of Onyx, we can check it out later. And I think here our experts bring out this concept for the main purpose is that to facilitate every app developer's work, because as we think if developers do in current way and they need to do every app based on different kind of runtime, different kind of hardware platform, and that will increase lots of development work for them. So that's why we introduce such IR layer to facilitate their work. And once they develop one app and through IR layers, and that will transform to every hardware that Unimatrix members use currently. So this, I think that's the main proposal. We want to introduce this concept, but of course we can discuss internally how we can introduce a more easy to use way from the perspective of user or developer or app developer.
Yeah, I agree that this ideally we would have one common intermediate format that can target all kind of devices. But I think today it's fairly easy to target CPU and GPU devices through intermediate representations like Onyx, for example. But it's a lot harder to target custom accelerators through such representations, because they many of those rely on offline tooling to do the conversion step, the conversion from the intermediate representation to the platform specific representation.
Yeah, I think you I got to your point as well, and from our side we think that this kind of situation goes wider and wider, and I don't know if I am an app developer. Of course, I need if an Unimatrix organization can provide some kind of approach to facilitate my work and to let me adapt a different kind of edge device manufacturers, and that will help me a lot how to commercialize my application into market. So this is the main reason we need to this should be one of the main reason we need to think about that. So ONX is just one proposition, but if we can have other better propositions, of course, we are very glad to support, advise, and working on that.
Maybe it's maybe the platform vendors have a role to play here. Maybe maybe one way to tackle this would be to push them in the direction to support these kind of open source runtimes like TensorFlow Lite or Onyx. Because I think that in an ideal world,
there's a background noise.
We would support like TensorFlow Lite and Onyx, and I think we would cover a lot of platforms by doing that. That could be one way forward.
Yeah.
Yeah, but I think at this point in time, we can't really settle for one format since, for example, Umbrella is quite different. So I think the current approach with Laravel supporting multiple model formats is a necessary evil, I guess.
Yeah, to handle multiple platforms and the relevant platform vendors today, I think it's needed.
Okay, so we're running a bit late now. Actually, I'm gonna skip. I had a presentation about a demo of Visual Studio Code, so I will skip that. And now we move ahead with the presentation from Huawei about MindSpore.
Hi, can you hear me?
Yeah.
Yes.
So, can you present or I should present?
I think it's free for you to present now.
Sorry, I'm using browser, but I was told the browser doesn't support the desktop share yet. Can you share the screen for me? I think Judith already sent you the slide with the PDF.
All right.
Okay. Maybe I can try to share.
Okay.
I can share it otherwise. I think.
That'd be great. Thank you.
Can you see my screen now? Can you see my screen?
Not yet. Okay. Yeah, I can see it now.
Is this okay for share?
Yes.
Yes.
Okay.
Okay. Hello, everyone. I'm Howard from Huawei, colleague of Judith, and today I will give a brief presentation about MindSpore, a new deep learning framework open source by Huawei, and some like interesting experimentations and we are looking at. Next slide, please. Okay, so very similar to TensorFlow, PyTorch, MXNet, all the deep learning frameworks you have already been familiar with. MindSpore is another open source deep learning training and inference framework. What differs is that MindSpore, I think, is the first deep learning framework that actually works for mobile, edge, and cloud scenarios. So that is one framework for developer to develop your model, and then with the help of the Huawei Ascend AI processor, you can deploy your model on like either scenarios, mobile, edge, or cloud. And we open sourced the MindSpore project at late March, at the end of March. So it's almost 2 months and a half month old now. It's a very new open source project, and you can check out our official website with the you can check out the English version you can choose on the website. And we host the code on Git and also GitHub. You're more than welcome to check out the source code yourself. Next slide, please. Okay, this is the overall architecture for MindSpore. So here are a couple like main components in MindSpore. So the first one is the front-end expression, what we call Mind expression. MindSpore uses Python. Its front-end API is very Pythonic, so anyone is very familiar with like TensorFlow or PyTorch Python development should have no trouble getting started with the MindSpore front-end expression. So AI developers are writing the models in Python, basically. But what MindSpore brings interesting feature is what we call the auto differentiation. So MindSpore supports a source code based auto differentiation, which I will introduce a bit in detail later. So the source code based auto differentiation basically relies upon compilation optimization techniques. So in MindSpore, we have a graph-based IR, which is like could be used for high-level optimization for the hardwares. So whenever a developer writes a deep learning model in MindSpore, when MindSpore execute that model, you actually organize it into a graph, and then the compiler will do the optimization on that graph, and then output the MindSpore IR code, which we call the source code based optimization. And then with the MindSpore IR, or if you want to choose, you can also export as Onyx IR. All those output from the front end goes into the graph engine. So the graph engine is for MindSpore is basically brings upon the power of Ascend AI processor to deep learning. So for MindSpore graph engine, we support the whole graph offloading onto the Ascend AI processor and be processed on the Ascend AI chip. The support of the whole graph offloading could bring very significant performance enhancement. And as I mentioned, so the Ascend AI processor has a lines of product that could cover like mobile, edge, and cloud scenarios. So basically with that, MindSpore could be a unified deep learning framework. But also MindSpore support CPU and GPU out of the box. Okay, next slide, please. So we have a open community with a similar governance structure to ONNX and TensorFlow and Kubernetes, if you are familiar with. So we have a technical steering committee composed by 14 delegates from various universities, companies, institutions. And next slide, please. On the development side, we organize our development into 6 special interest groups and working groups. So 6 are responsible for specific feature development, and the working groups are responsible for cross-SIG collaborations. Next slide, please. And we also have a couple of community partners from universities and also open source projects. Okay, next slide, please. Sorry. Okay, I will give a bit detailed introduction of several key features MindSpore brings. The first one is auto differentiation, which I mentioned earlier. So for any major deep learning frameworks, they all have the capability to support auto differentiation, which helps the developers to build the backward propagation graph automatically and save time. But each deep learning framework do the auto differentiation in a different way. For example, TensorFlow do the auto diff using the graph, very traditional graph techniques, which is not very friendly for Python development. PyTorch uses operator overload, which is very friendly to Python development, but it has a lot of consumption, runtime consumption when you use that. So for MindSpore is using what I mentioned, the source code based auto differentiation, which to be put in a simple way is source code in, source code out. So in MindSpore case, it will be the Python code in. The Python code actually represent your forward propagation graph, and then with many of the compilation optimization techniques applied, we'll eventually we export the MindSpore IR as another source code, and the MindSpore IR could be executed directly on the hardware. Next slide, please. Another key feature is what we call auto parallel. Auto parallel is done with the help of the Ascend hardware. So Ascend AI chip has the what we call the HCCL library, which can help developer who has distributed a large-scale setup to automatically do the parallelization. So traditionally, developers has to set a policy for your parallelization, and also they have to know how to shard the data or shard the model. But with MindSpore and Ascend AI processor, all the developer need to know is just put one sentence, one command that define the context for the auto parallel. For example, if they're using the 8 PCS Ascend chip, or they're using 16 PCS Ascend chip, all they need to provide is the number, and the hardware will take care all of the the sharding, the distribution, and all that stuff for the developer. Next slide, please. Okay, so as I mentioned, the auto parallelization and many other great features was brought about by the capability to offload the graph onto the Ascent AI processor. So Ascent AI processor is a ASIC hardware, and so the graph engine basically provide a native graph execution and will enhance the performance a lot. Okay, next slide, please. Sorry. So in addition to the many of deep learning features, we also provide some very useful tools. For example, we have our visualization tool called MindInsight, which is like equals to the TensorBoard. We support many of the visualization for developers, and including like histogram. So developers could get a good insight into the network. Next slide, please. And we have another tool called MindArmor. MindArmor is a model robustness evaluation tool. So it brings many of the fuzzing techniques we use for traditional software development into AI. So it can help developers to test their MindSpore model for various kind of attacks to make sure the integrity of the model. Next slide, please. And as I mentioned earlier, MindSpore support all scenario collaboration, which could be very helpful for like industrial usage or many other interesting applications. Okay, next slide. Okay, I'm gonna talk a bit on some of the experimentations we have been doing with MindSpore, which could be very related to Unimatrix and like the for the edge side of things. So the first one is MindSpore's support for WebAssembly. Next slide, please. So as you might already know, all the major frameworks has variations of JavaScript support with the logic of, many of the inference job need to be done in the browser. So if you have a JavaScript like TensorFlow.js or mxnet.js, you can do the inference directly in browser. But we believe that WebAssembly is actually the way forward. For those of you who might not be familiar with WebAssembly is a way to execute a bytecode natively in browser, which brings performance enhancement to the traditional JavaScript and like the V8 engine. But in recent development, developers also began to bring WebAssembly out of browser, but also to server, PC, mobile, and try. So WebAssembly will, in the future, might be a all scenario bytecode standard. So So anyways, we have started experimenting, like provide a native support for a WASM port of MindSpore, which means your model written in MindSpore could be exported as a WebAssembly module, a WebAssembly bytecode, which with the help of WebAssembly runtime could be run either on your browser or directly on Android or iOS or on server without any worry about the underlying hardware. So at the moment, we are trying to utilize some of the experimentation been done in TVM for the operator generation, and also utilize many of the WebAssembly codegen technologies that's already available. So if the WebAssembly experiment to be proved successful in the future, it will bring AI much more closely to the edge side, for sure. Next slide, please. So another experimentation we've been doing is around eBPF. Next slide, please. So if you are familiar with the kernel, the Linux kernel side of performance monitoring, then you definitely know what eBPF is. eBPF stands for Extended Berkeley Packet Filter. It's basically a kernel virtual machine that could directly operate on registers, which means if you're using the BPF filters, you can save a lot of the